All right, so we are on worksheet 6B, and this is really kind of a warm-up because all it wants us to do is draw a sketch of this, which we just talked about. Absolute value graph looks like this. And then tell me the domain, range, intercept, symmetry, continuity, end behavior, intervals on which it's increasing or decreasing. So it's good review. If it's just a generic absolute value, what's all the stuff from yesterday? So domain, anybody? Left to right? Range? And it can hit 0, okay? As long as there's not an asymptote or an open circle, it's touching, okay? Intercepts? Crosses both x and y at what point? 0, 0 is the only intercept. Again, I know this because this is the equation we're talking about. All right. Symmetry. Yes. Anybody? Even, odd, y-axis, x-axis, what's going on? Any kind of symmetry? Doesn't it fold across the y-axis? Are we still struggling with what that looks like? I'm kind of confused. No, we're good with what y-axis symmetry looks like? Okay. Which makes it an even function, right? Which is weird because it doesn't have even exponents. So you're thinking about that. Okay. What else? Continuity. Is it continuous? Yes. Okay. It's continuous everywhere. It doesn't have any breaks or jumps or holes. End behavior. As x approaches. Okay. How do I say left? Negative infinity. What is it doing? Positive infinity. As x approaches right, I would say, then it's going up as well. All right. Increasing or decreasing? How do you decide that? Read it left to right. So this branch from negative infinity until 0 is doing what? Decreasing. And the branch from 0 to the right is increasing. Does that help some of you review those ideas from yesterday? I think there might even be one more of these. Oh, this was on 6A. Is that what I'm seeing? Was it really at the bottom of 6A? After it was at the bottom of 6A? Okay, so those of you who are just confused what I was doing on the video, it's at the bottom of 6A. Okay, this one is at the top of 6B, right? All right, so what can you tell me about this parent function? Domain and range? Intercepts? The only one again is 0, 0. Symmetry? If I do this, and I rotate it 180 degrees around the origin, is it the same? Yes. So what is that called? It's origin symmetry or an odd function. Where was I on the list? Continuity? It's all continuous, right? No breaks or jumps. End behavior? I'm going to go fast. How do you say left? Okay, and what is it doing on the left? So y is also approaching negative infinity. On the right, it's going up, so it's positive infinity on both. Intervals on which it's increasing or decreasing? Does it have any maxes or mins? No. So it is all increasing. As you go left to right, the values just keep getting bigger. And I know it looks like it flattens out here at 0, 0, but if you put in negative 0.1, you get out negative, what are we doing, cubing it? 0.001 or something. It's anyway, it does move along. It doesn't stay at any one spot. So it's all increasing. Now concavity might be a different issue. Kind of looks like it's bending this way and then bending this way, right? So we won't go there today on that one. All right, transformations of a parent function. This is what we're supposed to be covering today, is learning about all the kinds of transformations. There are rigid transformations, which mean they change only the position of the graph, leaving the size and shape unchanged. Okay, rigid transformations. Anybody tell me what that might be? Wouldn't change the shape. No ideas? So if you shift it left or right, that doesn't change the shape, right? If you shift it up or down, okay, so all these shifts, vertical and horizontal, are rigid. Reflections, if you reflect something over the X or Y axis, you just flip it upside down, left, right. Does that change the shape? No. The things that would change the shape, okay, are stretches. So vertical and horizontal stretches will change the shape. We're going to talk a little bit about taking the absolute value of a function will change the shape. I don't know what else is on the list. All right, so the first one we're going to talk about is shifting something up, down, or left, right. It is, but yes, we're going to fill all this in here, okay? Yep, thanks for asking though. This is just a picture from the book, okay? Thanks. A translation, which is the word for slide. A translation is a rigid transformation that shifts the graph. It can shift up and down or vertically or horizontally, left or right, okay? These are rigid transformations. When you add something on the outside or subtract it, it shifts it up or down. So if you had this, that would move the parabola up too, right? Okay. If you do something inside the parenthesis, so you have this, it shifts it left or right. The problem is anything inside the parenthesis does the opposite of what it seems it should do. So normally I would say minus seems like we're going to the left, but it actually goes to the right. Okay? So that's what we need to put here. When we have, this is from your worksheet, okay? F of x plus k, the k will shift up when k is positive. What am I supposed to be writing here? Anything? When k shifts down if it's negative. I don't know, so maybe just an example. If we had x, I'm just going to use y because I'm too lazy to put all these f of x's in here. Y equals x squared plus 4. Y equals x squared minus 5. Those would be up and down, right? Sorry, guys. When you shift something up or down, do the x values change or the y values change in your original ordered pairs? Y values. All right. When you have this, it says if h is greater than 0, it goes to the right. But the issue is that this opposite, right? So if it says x minus 4, it's actually going to the right 4 because it started out with a minus in here. So it's the opposite. It's to the right 4, which would change which values? If you just move everything to the right, it's going to change x values. Okay, anyone can give me an example of moving to the left? Okay. And again, that would change x values. All right, those you did a lot of last year, right? Shift left, right, up, down. This is an explanation I found on the internet of why it's the opposite. It says when transformations are made inside of f of x, you're moving the function back and forth, but you do the opposite math, since if we were to isolate the x, you'd move everything the other side. So horizontal transformations or translations affect the x. It's, I don't know, I could show you the table of values, and it was an interesting explanation, but I'm just going to go with it's the opposite of what it seems. Does that work for you? So describe these to me without looking down below. What does this do? Shifts my v which way? Up 4. This one would be, it's inside, so it would be left 3. Okay? And this one, from the original function, what two things have happened? Right 2 and down 1. Okay? So the blue one is the original one. The first one went up 4. The second one went left 3. The third one, the blue one was original. The red, it went right 2 and down 1. All right, so we're supposed to practice with a cubic. I don't think you have this practice, but just describe for me what would happen. If this is my original, okay, so I have this graph, what would I do to it? This one would move it where? Down 5. So it would be the same graph moved down 5, okay? What would this one do to it? Okay, this would move it to the right 3, so it would look like this. This one, anybody? Left 2 and up 4, so it would be somewhere up there. We okay? Yes. Yeah. All right, reflections. This is troubling to some students. When you have the negative on the outside, think about what that says. Negative f of x. What is that changing? Y values, right? Because it's saying the opposite of the y. If you change the y values, instead of going up, I'm going to go down. So it's going to reflect across the x-axis, okay? If you change inside and change the x values, it's going to reflect across the y-axis. Is a parabola a good example? Is that going to reflect across the y? It'll be exactly the same, right? And that's because this is equal to this, right? So it didn't matter. So we'll use a different sketch this time to exemplify these. Okay, so if our original function was y equals square root of x, putting the negative on the outside, okay, so the original function was here. Putting the x on the outside would make all of the y's negative, and it would go down here. So it changes y values. If I were to put the x on the negative on the inside, it reflects it over the y-axis, so it's going to go over here. I don't know if you struggle with which is the which axis or which it flipped over, but students historically struggle with this on the quiz, okay? If you just remember that a negative in front of a parabola does what? Flips it upside down, yes? Okay, that's what you need to remember, that it's going across which axis then? X. okay? So reflected across the x. All right. So transformations, it becomes very important that you understand the order. If I were to put a 7 into this equation, or a 10, we'll say. If I were to put a 10 in here, what would I do first to it? Look right up here. No. First thing I would do is, yeah, 10 minus 1 is 9, right? I would do the subtracting, which means the first thing I should describe is what that transformation does. What does that do? To the right one. The second thing I would do after I square rooted the 9 would be to make it a 3 and then take its opposite. So the second transformation, I'm trying to help you by thinking about order of operations, guys. If I wrote negative 10 minus 1 plus 2, is that what it had? The first thing you would do would make that square root of 9. Then you'd say, well, this is negative 3. And then you'd get negative 1. So the first thing we did was we dealt with this. So the first thing we should list is shift it to the right one. Then the second thing after we square rooted was we did this, which is a reflection over which axis? When you make the whole thing negative. Reflect over the x. And then the last thing we did was dealt with the 2 on the back, which is shifting it where? Okay, so the order we do these in matter. Can I explain why? Where did it become negative? Over here, or what are you talking about? It did. That's why this isn't okay. I wasn't looking at this picture when I was doing mine. I was ignoring this. They're just trying to get you to see that the putting the negative on just the square root versus putting the negative on the whole thing would totally make it different. Okay? And that's what I was just gonna, I was doing this one. I was just talking about it over here. Sorry, I didn't realize that was so confusing. And it was. I agree. I was making it difficult. Let me do this. Okay? If I have this graph, guys, and I shift it, I thought maybe it would let me do that. Let's try again. Okay. Does anybody remember what it was? Left. And then it was reflected, right? And then up. Okay. So if I reflect it here and then up, okay? The opposite, the other option, where's my little undo? Okay, the other option, if I had gone left and up, and then I reflected over the x-axis, now I'm telling it to flip all the way down here because it's got to be from up there all the way down here. Do you see that those are two different things? The reflection after the vertical shift is different. All right. The next ones are dilations, and this is a struggle for students, okay? Dilation means stretch. All right, so if we multiply a 2 out in front, it's going to expand it vertically because it's changing the y. If we multiply a 1/2 out in front, it's going to compress it vertically because it's changing the y. Inside, this is where we get confused. And parabolas are horrible examples. If we put a number inside the parenthesis, it's changing the x values. If it's greater than 1, it actually compresses it horizontally. And if it's less, between 0 and 1, it expands it horizontally. Let me see what we can put in our notes right here. It's hard to tell, particularly on a parabola. It just says that you can't tell whether it's being shrunk or expanded. Okay, so expand vertically greater than 1. I'm going to use, so I don't know what's a good choice. I'm just going to make up a graph. I'm going to use this. Okay, which is not really a cubic. It's kind of wider than a cubic. If I put a 2, okay, if I call this f of x, if I want to graph 2f of x, it's going to change the y values, and what it's going to do is it's going to make it go up twice as far and down twice as far. Okay, the zeros stay the same. If I put a value between 0 and 1, like 1/2 f of x, then what it does is it takes my original graph, and the zeros stay the same, but it only goes above and below half as much. So if this had been -1, 1, on this graph it would have been -1, 2, and on this graph it would have been -1, 1/2. Does that help anybody see that? Do you want me to write the ordered pairs on there? Okay, this is where we get messy. If I have this same graph and it's currently going through -1 and +1 and doing this, okay, when I compress it horizontally, a value greater than 1 inside, so I have f of 2x, it takes the graph and it still goes up to 1 and, okay, let me try that a little better. It just now, -1 and 1 would be out here, and it has moved in. Okay, it's compressed horizontally in. The zeros change. They are now at -0.5 and +0.5. The x values are changing. If I put a 1/2 inside, it expands horizontally, so it still goes up to 1 and down to -1, but instead of crossing at -1 here, it's all the way out at 2. Sorry, there's supposed to be an X in with my parentheses. So, one more time. Anything inside the parenthesis does the opposite of what it seems. If you put a 1/2 in there, it actually stretches. You put a 2 in there, it actually shrinks. All right, absolute value. Absolute value on the outside simply takes all the y values that were down here and makes them positive, flips them up here. Absolute value on the inside, this is weird. It takes all the x values that were negative over here and gets rid of them. And what it does is it takes and makes everything to the left look exactly like it did on the right. So it gives the graph symmetry because absolute value is making it an even function inside. All right, so on the outside, let's just draw this real quick. If this was our graph, it would now look like this. It would go, all the x's would be positive, so it's changing y's. If this one won't work to do that, let's see. Yes, it would. No, it wouldn't. It would still be the same. If this was my original graph, okay, it would now have that same thing to the right, but the left would be symmetric, okay? The graph will have y-axis symmetry and the left will be cut off. Explains it pretty well. It's changing x's. Is that the last one on the side? Okay. So now we get to try to sketch some of these. All right, so this is the words. Do you have this example at the top, I think, of 7A? Is that right? Okay. says identify the parent function. Well, the parent function of this would just be the square root graph, right? Which looks like this. Describe how the graph is related to the parent function. So can anybody tell me what two things happened? And in the right order, maybe? A negative inside. Did anybody catch? Back, look up your notes if you need to. A negative inside is a reflection where? Negative inside is a reflection over left, right. You're right. So it's a reflection over which axis? The y-axis. Think of it this way. If there's a negative on the outside, it'd flip it down, right? So on the inside, it's got to be doing something different. And then once we, whoa, don't write that. Once we've done that, the second thing they did was a -1 on the outside, which would do right. Yes, vertical shift down 1. And if you just write down 1, I'll be okay with it, okay? I know there's some teachers, if you don't write horizontal shift or vertical shift, they won't take it, but I'm not that teacher, okay? All right, so here we go. Describe what would happen. I'm going to graph the parent function real quick. What is the parent function for this? Well, what's going on here? Is it a parabola? No, it's a what? Absolute value, right? So the parent function, f of x, is just the absolute value of x. So what kind of points are going through that equation? 0, 0. Okay, I have a 4 here. If I put a 4 in here, what am I going to get out? 4. 8, 8. If I put in a -4, I'm going to get out 4. If I put in -8, I'm going to get out 8. Okay, so there's my parent function. Now, what two things are supposed to happen? This first, inside, shift it left 4, which is actually a horizontal shift. I'll write that, but I don't care. And what is the 1/2 outside going to do? Compress it which way? Vertically, yep. Doesn't do the opposite. It does exactly what it seems when it's on the outside. So if I take this 0, 0 and I move it to the left 4, it's over here now. And it doesn't compress because it's already on the x-axis. Can't get any closer. Okay. This point up here, this one right here, if I move him left 4, but he goes half the distance back to the x-axis because it's only half as tall now. This point right up here, if I move him left 4 and only half as tall would be here, and I don't have much room to do other points, this one would actually move here. Right, left 4 and half as tall. Yeah, that would be there. All right, what's going on number 2? Parent function, anybody? What's the parent function? What is this going to graph as? Parabola. So x squared is the parent function, which at 2 would be up at what? 2 squared would be 4. We went over to 4 and squared it would be up at 16, so it's off the top of the graph by there. Okay, so there's the parent. What is 2x squared minus 4 doing? The 2 is vertically doing what? stretching it by 2, which actually makes it look narrower. But that's not, it's actually vertically stretching it up and down. So it's going to go up twice as fast. Okay? And the minus 4 is vertical what? Shift down 4. So I can't stretch 0. I'm just going to move it down 4 because 0 times 2 is still 0. All right, but this was up at 4 above the x-axis, but if I double that, it would be up at what? 8, but I also shifted it down 4, so it's actually going to be here, just going up faster. So this 4 should be up at 8, but then it should just shift it down 4, so it moves it back here. So it looks skinnier, but that's really only because they pulled it up. Parabolas are not good examples in my opinion because you can't tell what's going on. All right, this is an easy one we can handle. Parent function they give us. Give me 3 ordered pairs for this. Anybody? 3 ordered pairs that are on this function. Okay? 4 and 2 though, right? You'd have to put the 4 in and get out a 2. 0, 0 would work, right? If it went out to 9, does it go out to 9? Not really, right? 9 would be up at 3 because the square root of 9 is 3. All right, what are we supposed to do to it? 2 things. I couldn't even hear what they were saying, so. Okay. What's happening here, guys? Left 3 and up 1. So each point moves left 3, up 1, left 3, up 1, left 3, up 1. We good with that one? All right, what's a generic absolute value look like? Our f of x right here is 1, 1, 2, 2, 3, 3. Okay. 2 things are going on. What is this 2 going to do? Does anybody remember? Compress, yes. Shrink or compress, which way? Inside is horizontally. Okay, so it's changing x values. So it's at 1, it's only going to go over half as far and then up 1. Okay, but what else is happening? It's not really going up 1 because it's been reflect over which axis? So at 1/2 over, it's down 1. Used to be at 2 over, it was up 2, but it's half of that. So at 2 over, it's only down. Okay, hang on. I'm doing vertical. I just described vertical, not horizontal. So it's half. So instead of going 1 over and up 1, it went only half over and down 1 because of the negative. So when it used to go over 2, now it's only going over 1 and down 2. And it's doing the same thing on this side. Where it used to go over 4, it's now only going over 2 to 4. So here's my question. Can you tell that it was compressed horizontally versus stretched vertically? The answer to that is no, because this graph is identical. Moving the 2 outside at an absolute value does nothing. Okay? So this is a bad example if they really wanted us to get the idea. All right. Can we try this one? How about just give me the words, describe it. We won't even try to draw it. What happens? The absolute value is. First thing you have to tell me is what's inside here. So what's this doing? Horizontal, shift, left, 2. Then what? You really should, yep, but you should tell me this one next because that's the order of operations you would multiply. Say vertical stretch by 2. And then the last thing is vertical shift down 3. All right. So your assignment tonight, I think, what does it say up there? 7, 9, 11, 13, 22. Yeah, I think these are the right ones. Yes? Yep, these are the right ones. Okay. It does on the list over here on the left. Okay. So tomorrow we're going to start talking about piecewise functions. Our warm-up will be 7B. And the rest of the hour we're going to work on piecewise. And then we're going to have some work time on Thursday and Friday. And question time. So please be prepared with some questions. One of those work days you are going to get a packet to work on. So it's not just all about doing all the book work.